Hi everybody, in today's video we'll be discussing how do simple machines work. Okay, so at the end of this particular video you should be able to identify the different simple machines. There are altogether three types of simple machines, and they are determined by the location of where the fulcrum is, and also where um, the effort and the load is. We will also be discussing other kinds of simple machines, for example, what's an inclined plane and what's a pulley system. So, and after we have actually discussed what those are, we will also be understanding what are their uses. Okay, so how do simple machines help us do it? So in a way, sometimes some force, the amount of force required to do work is actually very high, in which our human body is not able to withstand. Like for example, if let's say I ask you to carry one large piano up 10 stories without any form of simple machine, we will be physically carrying the load, and it will take us a lot of time and a lot of effort. Just like the people who actually went to build the pyramids, where they have to lift heavy stones, and without simple machines like the pulley system, it's going to take an even longer time for them to construct the pyramid. Okay, so a simple machine is a device that makes work easier for us. So this is the definition of a simple machine. Okay, and what it does is, number one, it helps us to reduce the load, reduce the force needed to move a load. Number two, it also helps us to change a small movement into a large one. What this means is, by moving a little bit, like let's say you brake, you use your leg, right, to go and press against the brake of a bicycle. Sorry, you use your hands to press the brakes of a bicycle. Your whole amount of effort required to stop the bicycle is a lot lesser as compared to you putting your legs on the floor. Okay, so I repeat, so basically the amount of by having the small movement of your fingers pressing against your brakes on the bicycle, you actually helps to stop the bicycle as compared to you use your physical legs, right, to stand on the floor to stop yourself from moving in the bicycle. So you can see a small movement can be able to change into a large one. So next is to change the direction or position of a force. In a way, it's like, let's say you want the force to be in a particular position, or to exhibit a particular action. You can also do it this way. So what are some types of simple machine? We have three common one: the lever, the inclined planes, and the pulley. So the lever is generally one particular, like imagine it to be like a seesaw, where you have the fulcrum, the load, and the effort. Okay, and then the next one is an inclined plane. An inclined plane is just one particular platform which helps to let you actually move up or down, okay, with the aid of gravity. Okay, and then last but not least is your pulley. Your pulley system is where you have a physical pulley wheel attached onto a wall, and then you start to actually use as a rope to actually pull up the load. So that's another example. Okay, we will be discussing more subsequently. So a lever system is, it has three main parts: the fulcrum, the effort, and the load. Sometimes in some other books they will actually call this the pivot. So they meant the same thing. Now what is the fulcrum? The fulcrum is basically the fixed point where the lever turns. That means, right, when we say turn, right, it either moves in a clockwise or anti-clockwise manner. So anti-clockwise direction is moving against the direction of how a clock works, whereas clockwise would actually be how the clock movement, the minute hand, will actually move. Next is the load. The load is basically the object that you want to lift up or you want to carry, and usually we have the arrow downwards because of gravity actually pulling the load downwards. Then we have effort. Effort is the amount of force that you apply. Okay, it's the amount of force that you can use to overcome the load. So the greater the effort, okay, you should be able to lift the load. But at the same time, because of the lever system, you can use a minimal amount of effort and still lift up a heavy object. Okay, we will be seeing how it goes. So why is it easier to open a tin of paint with a long screwdriver, it's because because having the effort further away from the fulcrum, you need a smaller effort to actually move the load. So another example is, let's say, a physical door. You can see the fulcrum is here. So the distance from the fulcrum all the way until the effort is over here. So you can see the effort is actually far away from the fulcrum, and if you look at the distance between the fulcrum and the load, it's just this small area over here, and it's a lot smaller. So another example is, let's say, a door, okay, where you have the hinge which allows you to open and close the door. So these are the hinges, and this is the whole door. You will see the doorknob, right, is actually right at the end of the other side of the door. You don't really see the doorknob, right, that is very close to this particular area. If it's too close, it will take you a lot of effort to actually open the door. So by putting the doorknob actually further away from the hinges, you are able to open the door easily. So there are three main classes of lever. The first class is having the fulcrum in the middle and the effort and load between the at the above of each side. Next, we have the fulcrum at the side, but more importantly, not at the side only, but always imagine that the load is actually in the middle. And then next, the effort is in the middle. So in a nutshell, right, we always try to remember based on what is in the middle for primary, second, first class, second class, and third class lever. So for first class lever, okay, second class and then third class. This is only for lever. You have the fulcrum in the middle, you have the load in the middle for second class, and third class you have the effort. So you can remember it as FLE. Okay, so you can think of some acronym to remember this. This will help you. So these are the examples of the three class of lever. So in exam, right, what will happen is they will actually give you the examples and they will ask you to label where the effort is, where the load is, and where's the fulcrum. So how I usually do it is I will first focus on labeling where is the fulcrum, because the fulcrum will tell us which class of lever it is. Second thing is effort is where I exert force using my body. So effort can be in the form of using your body to actually exert the effort, and of course the load is usually the object. So these are some ways. So the fulcrum is like a supporting point. So you can see when you saw something, usually you put your hand here. So this is where the effort is. Okay, the load will be the load of the paper cutter, and then the fulcrum is where it's usually fixed. So the fulcrum should not be moving at all. You see, fulcrum is the point where it's actually fixed, it does not move at all. You use your fingers to put over here, and then the load is of course definitely the donut. Okay, so these are examples of how you can tell or label which are the class of lever. So how do lever make work easily? This is important. This is a common exam question where they ask you to explain. Okay, so please take note. First and second class levers, they make work easily by allowing us to use a small effort to overcome a large effort. Third class lever, on the other hand, enables small movement. So do see the difference in words. Now here's small movement of effort to result in large movement. So one is about using effort to overcome a larger load. The other one is about movement. The keyword here is movement. Movement, movement. So small movement to large movement of effort and load. So it's always about effort and load. And this makes work such as like sweeping the floor faster, where an effort actually leads to an effort larger than the load is needed. Okay, so these are some examples. So this one is a very common standard way of answering. Inclined planes are basically a flat surface. This is a definition thing. It's a flat surface with one end higher than the other. So it is quite self-explanatory, where it helps you to move. So rather than, you see, you do your maths, you realize that the amount of distance traveled to move sideways and then move up and down is actually greater than just moving in one inclined manner. So this helps to reduce not just the distance but the amount of effort as well. Okay, so which is easier? Definitely not carrying the load upwards but sliding it along. So moving a load up an inclined plane requires smaller effort as compared to lifting the load vertically. So in your answer, you must always do a comparison. You cannot just say that you move a load up requires more effort, then full stop. It's not enough to say that. Okay. However, the load has to be moved distance, over a long distance along the inclined plane. So this is more of the trade-off. The trade-off meaning this is what you are sacrificing in order to use lesser effort. That means even though, like for example, to lose weight, okay, you have to run longer distance. So that is the trade-off as compared to, so you can run, okay, like for example, to lose weight, you have to longer distance but you do a slow jog, as compared to you run very fast but a shorter distance. So that is an example of how you can actually compare which is better for you. So next, what is a pulley? I apologize for the fonts from moving away, but a pulley is a wheel. So a pulley is a wheel with a groove for holding a rope in place. So this is the definition of a pulley: for holding a rope or a cable in place. So this is very similar to the flagpole that you see in schools, where over here they actually have the groove to allow the flag to actually be able to lift up. So if you all actually try to carry the flag, even though it's a cloth, right, actually it's quite heavy when it's wet and things like this. So sometimes pulleys are also used in construction cranes and cable cars and cable and window blinds and yachts to actually raise sail. So this makes the amount of load a lot easily, where in a single fixed pulley system, the effort is equal to the load. Okay. Okay, there are also other useful applications of pulley system like the yacht, the window blinds, the cable car and construction. And in your textbook, they actually do a very nice summary of the different types of pulley system. So please refer to your textbook, okay, um, to look at how the different pulley systems are compared. And this is actually more or less quite similar to explaining. You will need to know how to explain how the individual pulley system work in a different situation. Okay, so do take the time to pause the video, recap what you have learned, refer back to your textbook for more information, as your textbook is really good in explaining all these details, all these things in greater details. If not, I will stop here for this particular lesson. We have already finished up forces, and do like the video, subscribe to my channel, and watch the next chapter. Okay, thank you and have a good day.